Welcome to the LIGO Lab at the MIT Kavli Institute. Here, scientists work on both the instrumentation and data science for the Laser Interferometer Gravitational Wave Observatory. This project involves two enormous and incredibly sensitive detectors that can pick up tiny ripples in space-time produced by the violent collisions of black holes and neutron stars. MIT researchers at the LIGO Lab are discovering new cosmic phenomena by listening to the universe like never before.
This is one of the main LIGO labs where we develop technology for gravitational wave detectors. Our first big gravitational wave discovery was from a pair of black holes that merged into each other. And so it turned out that those gravitational waves came from black holes that were each 30 times the mass of our sun. And that was the first time that we discovered black holes of that size actually existed. And then we've had many more detections of black hole mergers since then, and we're starting to sort of fill out the picture. What does the population of different sizes of black holes look like across the universe? And that can help with understanding how the universe evolved.
My name is Maggie, and I'm a graduate student at the LIGO Lab at MIT. In our lab, what we focus on a lot is really developing a whole kind of core of these hands-on skills. So I remember in the early years, I spent some time working on circuit board design, for example. Some other ones that we do are kind of 3D modeling and design. So you can do some work in the machine shop, for example, machining aluminum parts. So yeah, we try to really cover a whole bunch of different skills, and because in the end, you need to do all of these things. I remember when I showed up, right, there are a lot of things in the lab where, I look at the equipment and I had no idea what anything was. And so over the years, really spending time there and being able to go from not recognizing anything to being able to, turn on a laser, run the laser, make measurements. And eventually we built the squeezer kind of from scratch.
My name is Jeffrey Moe. I'm a second-year graduate student in the MIT LIGO Lab. There are people here who work on all aspects of the instrument. So you have just decades of institutional experience and knowledge. If you're interested in working on this or that, or if you want to learn more about a certain topic, it's probably the world expert in that topic is down the hall. If you want to really be immersed in all aspects of LIGO science, MIT is one of very few places that can do that.
I think one of the things that makes LIGO a little bit special to me is that, because we have so many staff scientists and staff engineers, postdocs, you really get to work with a whole bunch of different people. In some sense, it just felt like one really big family. I picked it for the science. The science is very interesting, but I think I also picked it for the people.
Up until 6 years ago now, we hadn't detected gravitational waves. We didn't know if black holes exist in binaries, and now we've detected tens of these types of systems. It's a really new field, and we are literally discovering new things that humankind has had no access to before, like the early universe. So the cosmic microwave background is the farthest back in time that we can look with light, but with gravitational waves we can probe back past that, and we can look back to the moment immediately after the Big Bang. It's just really exciting because we're able to look at new things that we haven't been able to see before, and potentially learn what happened at the very beginning of our universe, which I think is pretty cool.